All right. Good evening, guys. How are we? Hope you're doing well. It is the 15th of March. We are halfway through March already. It's unbelievable. Yeah, we've had 2.5 months of the year gone already. We are about 1.5 months away from your exams. It's getting closer. It's coming thick and fast. Hi, everyone. Hi, Yellow Yeti. Hi, Imran. Hi, Debashri. Good to see you all. TKD, good to see you. Strawberry Cheesecake. Hello. Amira, hello. Today's topic, Debashri, is on a bit of nuclear radiation. Yeah, so things like basically like the different types of radiation and their properties, and then also a bit on nuclear equations and things like that. So I'm going to cover that. A couple of topics there today. And for those of you that are new here, welcome to Revise for a Prize. Yeah, so Revise for a Prize, we are offering you a chance to win an Amazon voucher. Yeah, the real aim here is we want you to learn. Yeah, we want you to take part in our quiz, have a bit of fun doing it, and hopefully win a prize at the end. Keep it like some friendly competition. But the aim is we're covering a couple of topics every single one of these lives, and we're going to go through a quiz once we've covered a bit of the content on it, so that you can see what's kind of going to come up in there, and then I'll quiz you on it at the end. So we'll be about doing that for about 20 minutes or so, covering some notes and stuff, and then we'll get into the quiz. So in order to successfully get your voucher, firstly, you will need to win the first or second place. First place gets a £25 gift voucher. Second place gets a £5 gift voucher. And you will do that by joining our Kahoot. So I will drop the Kahoot quiz pin first of all. So go to www.kahoot.it. Our Kahoot pin for today is 4443613. So I'll put that here, 4443613. Okay, so that's our code for today. Join in. As usual, I always tell people, let us know who you are. Marvelous Bunny first in the chat. Will they be the winner? Let's see. So I'll wait for this to go. I'll let people join whilst we're covering the session, because the other point is I want to see, or we need to see, a screenshot of you interacting in the chat during this revision session, okay, to show that obviously you are taking part in the session. Sometimes we don't want people turning up, getting into the quiz that haven't actually participated in the session at all. Yeah, because the key thing we want today is learning. Okay. So yep, as Philip says, we want to give you more prizes. The way we can do that is to get more people. Okay, we're at 20 already. We've had 28 before. We want to keep stretching that. We want to get to 50. If we get to 50, it means we can then be able to give you even more prizes and bigger prizes. Yeah, so please do, if you know anyone that's doing their GCSEs, any of your school friends, get them to join the session, and then we can all do this together. Yeah, so we'd love to see that. So a couple of points to note before I start as well. We have our Easter boot camps coming up. Okay, that is going to be a session on paper 1 and a session on paper 2 for each science. Session for paper 1 is completely free. Okay, you can sign up if you want to sign up. I will drop the link in the chat now. So you should see that there. Click on that link and it should take you to our page, which is here. You can see we're enrolling. Okay, so you can click sign up now. You can have a look down. It's going to be myself and Neen. So Neen's going to be covering biology and chemistry. I'll be covering physics, and we'll be doing a full day session on each. Okay, so it's going to be like 4 hours of teaching on each class. You can see everything here that you're going to be need to know about them. You're going to get a revision guide for paper 1 and a revision guide for paper 2. Okay, if you go down, you can see you want to reserve your spot. Click reserve your spot. It takes you down to the bottom here. Enter your name and your email address. Those of you that have FRL classes, you do not need to do this. This is for people that haven't joined FRL classes. Okay, and you can see here we are doing a free offer for everyone on paper 1. Okay, so you can come and join paper 1 if you like it and you want to join us again. We will be doing our paper 2s following that. Okay, so they are just for £10 each at the moment, guys. So if you want to join, tick the ones that you want to join and then say let's get you booked, and you will be able to sign up. Paper 2 isn't free because we need to be able to keep ourselves going somehow. We can't give everything for free, so it is only £10, and that is for 4 hours each, 12 hours of teaching. So 4 hours of teaching for £10, £2.50 an hour. Yeah, so it's basically free. Yeah, it's as cheap as we can make it to make ourselves carry on with what we're doing. So we're doing what we can for you guys. Would love to have you there. So please do sign up if you can. But again, for the people that are on FRL classes, you do not need to sign up for this. Okay, this is included in your package. So for those of you that aren't with us and do want to join FRL classes, that is our monthly package. Okay, where we do classes every week, one physics, one chemistry, one biology every week anyway, and you get those classes every month for £22. Okay, these and in this case for the Easter boot camps, those are included in that subscription. So really, instead of £30, you can get it for £22 and you get all 3 sciences, and you would then be able to join our classes. We have a class next week, actually. You can join that, and then you will get all the Easter boot camps as well. So take a look. If that's what you would like to do, you can do that, or you can join just for the individual sessions. Whichever way, we've left it flexible to let you do what you need to do, and hopefully you will join us. Yeah, so we'd love to have you with us. The sessions, what time are they going to be? I'll scroll up. It is all in here. Let me have a look. There we go. So here, roughly 10 a.m. to 3:30 p.m. Okay, so start at 10. We do about an hour. Then we'll give you a break. Then we'll do another hour, and then we'll have a lunch break for an hour. So you can see we end about 12. Have about an hour's lunch. Then we'll have our third session for an hour, another 15-minute break, and then another hour. Okay, so we split it up into 4 sections. For me in physics, let's say for paper 1, it's in 4 topics. If I go back to our spec 1, 2, 3, and 4, these 4 topics are in paper 1. So that covers us nicely for paper 1. So I'll do 1 topic per hour. Okay, and all of that, we'll have the revision work guide that you will go through, follow with me, and then you'll have a full revision guide of notes for paper 1 come the end at 3:30 p.m. Yeah, as you said, it's going to be, we'll confirm the link when you get it. It'll be Zoom or YouTube. You will have the link when we send it to you. If you sign up, once you sign up, we'll give you the individual link, and then you'll be able to join from there. And then you just check, it's the one link for the whole session. Okay. But yeah, trying to break it up basically to give you some breaks in the class. And then here we are, just a breakdown of the sessions. Yeah, so please do take a look. I've posted the link there in the chat. I'll just drop it again because there are some chats in there. Is this better science? All the science Excel is based on AQA over between the other boards. Okay, and sometimes like what's in paper 2 for AQA, maybe in paper 1 for the other boards. So it's just, yeah, so definitely beneficial. Absolutely going to be covering the main topics that you're going to need in all 3 of your sciences. Cool. So if you can, please do sign up. We'd love to see you there. I'm going to start on some of the content for today. FRL Pro doesn't get the bootcamp with its FRL classes, guys. Yeah, FRL Pro is what you get for this website, right? You get all the questions, all the quizzes on the website, but it doesn't give you access to the bootcamps. The paper 2 bootcamps you get for free with an FRL classes subscription, yeah, for $22 a month. Cool. So today's topics, we're looking at, in topic number 4, atomic structure, we're looking at chapter 4.2, okay? And in particular, these first 2, radioactive decay and nuclear radiation. This is combined, okay? This is combined. Boot camps, I may mention a little bit of triple, but only at the end, yeah? So we'll cover mostly all the combined stuff, and then I'll save the triple for the end, so the guys that finish combined can go off a bit early, and the guys that will triple cover the rest of it in the session, okay? And for today, though, the quiz is going to be on combined. Okay, and these 2 topics, this whole topic list is based off of combined. On our website, you can go and choose between combined and triple, and you can see the additional topics when you click on triple on our website, flashrevisionlab.com. So let's take a look here. Radioactive decay and nuclear radiation. So when there is an unstable radioactive nucleus, it basically wants to give off radiation to become stable. Okay, and when it emits that, we call decay, when you remove that radiation from the atom. Yeah, it gives it off, and the radiation is now, it essentially dies, yeah, decaying, like a decaying fossil. It dies over time. Yeah, so it dwindles away. You have a test on this on Tuesday. Nice. Okay, so hopefully this is useful, more than useful. Okay, so we're going to look importantly here what it involves. So decay or a radiation, the way in which it decays over time is referred to as the activity. So that's the number of decays per second. Okay, that is called activity, and it's measured in the unit becquerel. Every scientist wants to keep their name in history. The guy that came up with activity, his name was Becquerel, so the unit is named after him. The important thing about radiation is that it's random, right? So the decays don't happen like at a set rate. The activity won't be a fixed value all the time. It's varying, right? Because it's a random process. Think of it as rolling a dice and trying to get a 6. You don't get a 6 every time, right? It's very random. and you won't get it every. The probability is 1 in 6, but it doesn't mean every sixth go you're going to get a 6. That's not how it works. It's very random. You can get 2 6s in a row. You can get no 6s for 10 goes. Very random. Yeah. So that's how radiation works in a similar way. The quantity of decay really varies because it's completely random. Okay. And to measure it, exactly, not predictable, as you say there. Yeah, it's not predictable, but we call it a random process. Then for the different types of radiation, we measure them using a Geiger-Müller tube, a GM tube. Has anyone used it at school? You hold it near a source and it starts to click, 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 click. That's a Geiger-Müller tube. Yeah, and the number of clicks we count in a specific amount of time, let's say a minute, and the minute is what we call the count rate here. Okay, so that's called the count rate. Cool, nice, good to see you have. I remember even I used it when I was at school. Yes, we're talking a while back, but it's an experiment they tend to show you how radiation is in the environment. And even that click, you probably noticed even from the clicks, is very random, right? It's not a steady rate of clicks. It can be suddenly spiking or it can be very slow. And that really varies because the radiation or radioactive decay is a random process. Okay, and the key thing in this topic, you need to know the different types of nuclear radiation. There are 3 types: alpha, beta, and gamma. Okay, so alpha, I'm just going to put some notes here as well alongside the table. So alpha is a helium nucleus, yeah, positively charged helium nucleus. So we give it, like in chemistry, when you look at the periodic table, you give it a mass number and an atomic number. Yes, the mass number referring to number of protons and neutrons, meaning there's 2 protons and 2 neutrons, giving it a mass number of 4. Okay, and it gives it a charge because there's 2 protons, and it's a nucleus. It has a charge of +2. Okay, so we say a positively charged helium nucleus. That is alpha. Okay, then we have beta that we've written there. Beta radiation is given a number 0 as the mass number because there's no protons and neutrons, and -1 as the atomic number, because usually that refers to the number of protons. In an element, a proton usually has the same number of protons and electrons. In this case, it's just a high-speed electron. That is what a beta particle is. So we can tell that by having an atomic number of -1. So this is a high-speed electron. And for those of you that were in my FRL classes session just earlier, the last one is gamma rays. Gamma rays 00 because it's a wave. And what type of wave is it? An EM wave, an electromagnetic wave. Okay, has 0 charge, 0 mass. It's not a particle. It is a wave. Okay. Is it the protons or the neutrons that determine an element? It's the protons. Yeah, what we call the atomic number. So the bottom number is what determines what element it is. Okay, the top number is the number of protons and neutrons, what we call the nucleons in an element, okay, in an atom. So what we then want to compare is the properties of each of these. So we've talked about charge. We said helium is +2, an electron of beta is -1, and then the EM wave is a high energy wave. It has no charge. It's neutral. Then we compare these 2 properties. Can anyone tell me I'll start with the easier one, hopefully. Penetrating power. What do I mean to penetrate something? What does that mean? Anyone tell me? Going through something. Yeah, so how far it goes through something. How strong it is to be able to go through stuff. Yeah, and in this case, between alpha, beta, and gamma, gamma is the most penetrating and alpha is the least. And they also ask you what each of them are stopped by, yeah, what they can't penetrate. So alpha is the least penetrating. How easily it is blocked is a good way to put it as well. Yellow Yeti, good answer there. Yeah, so go through something. Everyone's got it. Nice. Yeah, so in terms of comparisons between them, alpha is the least penetrating, and it's stopped by either thin paper, skin, our body skin, or a few centimeters of air. Yeah, so each one we kind of talk about their range in air as well. That is centimeters of air. Beta is in the middle, so we say it's moderately penetrating, and that is stopped by an aluminium sheet, aluminium foil. You can't pass through that. So something slightly thicker than paper, but still not that much. And then gamma is the most penetrating. It can really go through stuff. You need thick concrete or thick lead. So a big block of thick concrete or lead, that's what's going to stop gamma from penetrating. Yeah, so you can see it's very highly penetrating. Ionization power, ionizing power. Do people know what that is? Anyone tell us what ionizing power is? So the clue is in the word ion. If you've done it in chemistry, you will know what an ion is. An ion is basically an atom that becomes charged, right? So it has a positive or a negative charge because there is an imbalance between the number of protons and the number of electrons in the atom. Yeah, so how easily it loses electrons. Exactly, Shadow. Really well answered. Yeah. So how easily it gains or loses an electron. In this case, ionization usually knocks electrons off of it. So an ion is a charged atom essentially, and the ability for it to become a charged atom is the ionizing power. Correct. Yeah. And by ionizing, alpha is the most ionizing. So you can see the order reverses here. It may not penetrate very far, it may not get through your skin, but when it's in your skin or in your body, it's very ionizing. Okay. So it can damage cells in your body. And then beta again is kind of the steady eddy. It's in the middle. It's moderate. And then gamma is the least ionizing. They're all very dangerous. Okay, someone mentioned this in the class today. We spoke about this briefly. They're all ionizing, so they're all dangerous, but the level of danger is different with each. Okay, so it's still ionizing gamma, but it's just lower than beta and alpha. But alpha is definitely the most dangerous, the most ionizing. What is the best way to revise for physics strawberry cheesecake? Go through some notes, maybe make your own. We've made some for you, so we're kind of trying to cover that step using the website. Then try some questions. Yeah, you want to practice some against some questions. So we've got a few ways to do that even on our website. Go to questions here. You got some exam questions. Click on question one. You can see we've got different types of exam questions here for you to answer. Yeah, varying different types of past paper question. So give them a go. You got mark schemes to check, and then I'll check. If you know it, then you would have got, you got the answer right. You check, great, you know it, you can move on. But always come back. Yeah, it's all about repetition as well. Practicing different questions of the same topic, doing as much practice as you can. Yeah, which is why here, for example, we've got 12 questions, really trying to make sure you understand the topic. We've also got flashcards here. So for those of you that have FRL Pro, it's only a few pounds a month. You can get all these flashcards. So these are just prompts to test you on your knowledge in the topic as well. Okay, so you can have a look, tag what you know, swipes to the right. Anything you don't know, swipes to the left. Yeah, so you can try that as well. So any sort of note taking and memorizing of those notes, followed by practicing questions in physics in particular. Yeah, kind of similar to the way that maths is, and with all your sciences, I would say you want to do some notes and then try some questions to make sure that knowledge has stuck into your brain. Obviously, you can refer to the spec here as well. I didn't mention earlier. Everything I'm mentioning is covered in the spec, as you can see here. We're talking exactly about what each type of radiation is. We're talking about that. We talked about what activity is, what it's measured in. We talked about count rate. So everything we're covering in the notes is exactly what's in the specification. So we're trying to just give you literally exactly what you need to know. No faff, just straight to the point. Yeah. So as long as you have a set of notes, which you do here, and you practice some questions, that is what these are. Yeah, so some of the questions are locked. That's because you are signed up as a free member. If you get FRL Pro, you get access to everything. Yeah, so it's just a few pounds a month, less than a coffee a month. You can get FRL Pro, and that gives you access to all the questions. None of them will be locked. Yeah, that's the difference. So you can get access to that. Yeah, and then like I said, FRO classes is where myself and Neen are doing classes every week. A few of the guys in the chat have been with us and have found it useful. And that's what we're doing to cover everything. And it comes with a workbook every session with questions to practice as well from those lessons. So as well as that, they're going to have the revision guides as well from the boot camp. So really just a full set of complete notes, nothing else to do once you've done that. And that will be your note side covered. Then it's reading it, taking it in and practicing, applying it. Yes, taking it in, reading it, and then spitting it out into exam questions. That's the way to practice. Cool. So here we also mentioned some uses. Okay, so beta particles are used in things like measuring or monitoring paper thickness. Alpha particles are used in smoke detectors because when smoke appears, alpha can't pass through it anymore. The alarm goes off. Yeah, that's an example of alpha. Beta here, see monitoring thickness is used for materials, so paper, metal sheets, things like that, because beta can pass through to an extent, but it will vary depending on the thickness. So because of its penetrating power being moderate, so it sits in that good level where if you used alpha, it would never pass through, so you're not going to tell the thickness. And if you use gamma, it will always pass through easily, so you won't know the thickness either. Beta is the best for material thickness measurement. And then gamma rays, their main uses in medical applications, yeah, radiotherapy for cancer treatment or medical tracers. So you say, for example, you want to monitor the flow of something in your body, they will get you to ingest or eat a source of something with gamma in it. So they can observe it because it can be detected outside the body and they can observe its motion in your body. Yeah, things like that. So those are the uses, okay? So that is three different types as well. So you need to know all their different properties. This is a very, very, very important tool, okay? Because questions come up on it all the time, exam questions, and there may be something in the quiz as well. Quite a few things on it. Cool. So we've covered a topic. If you're on the website and you want to make sure you've mark it as complete, spin the wheel for a bit, and then you will see it's ticked. Yeah. So then whenever you return to our website, you will see that we have then got this topic marked as complete and the bar is filled. Yeah, because I've done one of the 4 topics here. So I'm going to move on to the next bit just for a few minutes. It's not a long one. It's talking about how the different types of radioactive decays look in different equations. Okay, so here we have a nucleus before the decay. It's got that radiation in it, and then it's going to emit that radiation and give you a different nucleus after decaying. Okay, we're not doing all 4 topics, just the 2 topics today, Demetri. That is it. So not a long one, but there is going to be about 12 questions or so on it today. Okay, so as we mentioned, we've got the symbols. So these are the symbols you may see in an equation, in a nuclear equation. And then for gamma, you'll see 0, 0, as I've written here as well, because it has no charge and no mass. It's not a particle, it's a wave. Okay. So starting with alpha decay, you can see if its radiation is given off, we know an alpha particle being given off means it has a mass number of 4 and an atomic number of 2. Okay. So that means a nucleus that was starting with that will lose that amount. It will lose a mass number of 4 and an atomic number of 2. So 219 minus 4 is 215, and 86 minus 2 is 84. So that's what you're going to see here. Yeah, so I'll talk through it again. You can see 219 turning into a polonium atom and then releasing alpha particle, which we said can either be the symbol alpha or He because it's a helium nucleus. And you can see it's basically maths on both sides. So 219 is what radon has on the left. We need a total mass number of 219 on the right. So you find the difference. And then same with the bottom, 86 on the left, it needs to add up to 86 on the right as well. So what plus 2 equals 86, that's going to be 84. And then on the top, what plus 4 equals 219, that's 215. There we go. Nice, Sammy. Yeah, and that's what you put for your answer there, for example. Okay, and that's the final equation. So that's what alpha looks like. It's probably the second most straightforward. You just subtract the difference. Yeah, exactly. It's maths. Yeah, so you're just looking at what the total on the left, total on the right has to be the same. So you do subtraction to work it out. Perfect. How do you know which radiations you use? That is all based on the numbers. Yeah, so if you look at the atom, so sometimes they'll give you, and I'll put it on here, they may give the question like this. So 219, well, I don't know why I'm putting an arrow there, 219 Ra86, and then they'll put this 215 PO84, and then they'll say plus what? And you'll need to know that. And that is because we can then find the difference, right? So then the difference here is 4, so we know it has to have a mass number of 4, and we've lost a mass number of 2. The only with that mass number and atomic number is alpha. Exactly. Alpha is 42. Yeah, that's an helium nucleus because it's got 2 protons and 2 neutrons. So therefore giving a mass number of 4 and an atomic number of 2. That's how you know it. Okay. If it gave a beta decay, which we're going to go on to next, you'll see the numbers behave slightly differently. Okay. Here, you got beta decay as this, 0 minus 1. Okay, so if we've got a carbon nucleus we're using here this time, and it gives off beta radiation, this is what we have. We have 0 minus 1 on the right, okay, because a beta particle is given off. So in the same way we did earlier, we're looking at the maths on the left, the number on the left. What we notice at the bottom is that the atomic number was 6, so the number of protons is 6, and then you look at the total here is x minus 1. Yeah, so x plus minus 1 or x minus 1 equals to 6. So x equals 6 plus 1. The atomic number actually goes up by 1. Yeah, so you see in my example before for alpha radiation, it went down by 2 because an alpha particle is given off. Here, for beta radiation, you'll see atomic number increases by 1. Yeah, so if I put that equation here in full now, 14C6 goes to 14N7 plus, and I'm going to put beta, or you can put E0 minus 1. So you can see here, for beta decay, the atomic number increases, but the mass number stays the same. And the reason for that is that means you've got the total number of protons and neutrons stays the same, but the proton number has gone up by 1. That means the neutron number is decreased. So basically, in beta decay, a neutron turns into a proton. That's the change you're getting. But when you emit an when you emit a beta particle or a high-speed electron, a neutron in the nucleus turns into a proton, and this is the equation you get at the top. You see the atomic number change, and then the mass number stays the same. Yeah, so again, it's all by maths. So up by 1 because neutron decays into a proton and electron. Exactly. So the neutron turns into a proton, and then you're releasing an electron as a result of it. Correct. Yeah, so that is the difference between simply by maths, looking at the total number of mass number and atomic could equal the total sum of mass numbers and atomic numbers on the right-hand side of the equation. And now I said alpha was the second easiest because gamma is absolutely the easiest. Okay. Why is that? Because it's not a particle. It has a mass number of zero, an atomic number of zero. The atom that is there at the start stays the same at the end. Yeah. So the atomic number here, for example, uranium, it has a mass number of 238 and an atomic 2. You emit gamma, there's no change to the particle structure. So it stays exactly the same. It's just more stabilized because it gave off energy in the form of gamma rays. Okay. So the atomic number stays the same, the mass number stays the same. That is why I'd say um, the gamma decay is the easiest because, as I've put the last point here, the starting and final nucleus stays the same. You just put plus gamma on the end. Very, very easy. Yeah. So gamma's easiest. Then I'd say alpha, and then because of the -1, beta is probably the most difficult. And you always have to understand that the neutron turns into a proton during beta decay. And that's it, to be honest, guys. Yeah, so bit of a brief one. We've covered the topics. I've ticked that off. We've done 2 topics. I'm just going to check the spec again just to show you we've covered everything that we need to in this subsection 4.2. I go here, it says 4.22. We've got what the different types are. We've talked about different examples of equations, literally the 2 that we had in the notes, and we've explained them. Yeah, and it says beta decay does not cause the mass to change, but does cause the charge to change. Yeah, that's what we explained because the neutron turns into a proton. Yeah. And the emission of gamma does not cause the mass or charge of the nucleus to change. We also mentioned that. Okay. So there we are. We've covered everything there. This is what the quiz is going to be on, guys. So that is the end of that. I will put the pin back up. Sorry, someone has requested it. Sorry about that. Now we're going to get to you guys joining. I'll leave it here as well. 4443613. Only 11 people joined. We have about 20 of you in the chat, so please do get in there. Who's who? Has anyone mentioned their names in there yet? I don't think so. Let me know who you are. Philip, I know you're not going to let me know. Debashri, are you not going to let me know either? I know in the past, last time I saw your names, you did not give your name away. Is that a tactic to stick to? Is the screen hazy? Or maybe there's a little bit of lag for people. Apologies if there is. Bear with me. It will be there. Join the Kahoot and look at the Kahoot, okay? Not the video. Don't don't follow me by the video. Go by the Kahoot because that's going to change first. Yeah, because then I don't want you to lag behind and then it will cost you in the quiz. The first question is a poll today, very quick one, but it is a poll. So we're not going to go straight into a question. We will do a poll first. You can't tell your identity unless you win. I completely get that. Yeah, I'll wait to hear from you at the end. But yeah, just before we do start, guys, whilst more people are joining, I'm going to mention it again. For those of you that aren't with us on FRL classes, do join our boot camps, our Easter boot camps. Yeah, not far away now. I'll get the dates up here again. We are starting from, go to the timetable. You can see, starting with physics with myself on the 29th of March, Sunday the 29th. Yeah, so I'll be covering paper 1, 4 of those topics, including part of what we're looking at, radiation topic that is going to be in that session. And then Neen will follow up with biology a couple of days later, and then chemistry a couple of days after that. And then we have a little break before we get into paper 2, a few days before Neen starts paper 2 biology on the 7th, and then chemistry on the 9th. And then I will finish off the paper 2s with the last session just before you go back to school on the 12th of April. Okay, we give you a revision guide with each of those, a very, very thorough revision guide. People last year absolutely loved it, so this is why we want to do it again. The first classes, the paper 1s, are completely free, so you can get on the Kahoot now. I've left the quiz here, and then you skip the first part. Yeah, we'll see how you get on. If you do, you can join. You can send us a screenshot. You've messaged me here, so see how you get on. Message me at the end if you're at the top 2. Good luck. But yeah, if you are available on those days, obviously it's the Easter holidays, time to really lock in for revision. So we would love to see you there. You can just sign up for free onto these 3 on this website. So please click on the link. I've shared it in the chat, and it takes you down to the bottom here. When you go to sign up, click on the sessions you want to join. So obviously at least these 3 you can join completely free. And then these 3 are only 10. If you want to join FRL classes, where we get all our weekly classes on top of that, is £22 a month. So it's actually cheaper than doing the individual paper 2 classes. So take a look. Please do join us and let us know. And we look forward to seeing you there. Okay, it's clearer now. It's the paper. Yeah, so the paper 1 stuff I'm telling you is fully free. So you just need to click sign up here, and then you'll be sent a link to your email with a revision guide and the link to the session. And that is for paper 1. Those first 3 days are completely free, guys. So sign up, take part, and we look forward to seeing you there. and then hopefully you enjoy it and you'll see us for paper two as well. Yeah. So if you want to join paper two at a cheaper rate, like I said, just get our subscription because it's £22 a month. Yeah. And that gives you all the boot camps and all the live classes that we're doing. And then there'll be cram classes that we're looking at doing maybe closer to the exam time themselves. Yeah. So plenty to get from the £22. So yeah, really, really a good offer, I think. So yeah, take a look, see what you think. And look forward to seeing you there. Plenty of FAQs on there. Obviously, email us as well if you have any questions. Help@flashrevisionlab.com. I've got it written down here as well, where we want you to send your quiz winnings if you win as well. Yeah, the same email address. Let us know if you have anything, but hopefully the website covers it all. And yeah, look forward to seeing you there. Cool. So 15 of you. There is a 20 in the chat. I want to give it another 30 seconds. 30 seconds for people to join before I make a start. Hopefully, you guys, we have two winners here today. Hopefully, it's you, whoever you are, all the best. Give it your best shot. Yeah, I just make sure if you were here, I guess whoever said they just joined, they are missing out on what we covered today. They don't know what exactly is in the quiz. So all the best. But yeah, even if you haven't joined, you're just joining now, you can take part in the quiz. But in terms of the winnings, usually it's for the people that haven't messaged and taken part. Yeah, so it's paper one. This is radiation, yeah, which is the last topic in paper one. Cool. I think that's everyone. There's 18 here now. I'm going to give it another 5 seconds. Are we ready to go? If you can still join while I'm doing the poll. Yeah, and I've left the code here on the left-hand screen, 4443613. I'm going to press start. Good luck, everyone. Starting with a poll. Yes, it is a poll first, Debashri, don't worry. So it's giving you people, anyone else here, the 20 of you, there were 3 of you that didn't join, do join. You've got a few seconds to do so. So it's a scale. Are you ready for your GCSEs? Okay, with 1 being a hell no and a 5 being a hell yeah. How are we feeling? Are we feeling ready? Are we feeling almost there? Are we feeling nowhere near? I just want to gauge how people are feeling at this stage. A couple of weeks before Easter, you should really be starting to revise at least. Yeah, hell neutral. Yeah, I like that answer. Yeah, you're at 3. Fair enough. Yeah, I'd like to see where everyone is. Do people agree with you, or are people less prepared, more prepared? Let's have a look. I'll show the answers. Let's see the split here. Most people, yes, okay, a hell neutral. Yeah, a lot of people agree with Debashri. They are in the middle. I'm happy to see that. Okay, more people on that end than the left-hand side. For those people that are 1 and 2, it's not too late. Okay, but it is time. So I would say get into it now, because now is the time to start revising. Yeah, we're really getting close. When you get nearer to those exams, all your exams are going to come at the same time, and you're going to be revising 1 exam at a time. So where you think, oh, I will cover it then, you'll have a lot less time to do it. Okay, so now is the time, especially as we get into Easter, and then Easter you can really, really knuckle down. So yeah, if you haven't started, I would recommend please start now. Yeah, if you want to avoid disappointment and give yourself the best possible chance you can, now is the time to start. And for those of you that are 4 and a 5, nice, good to see. Yeah, some people are feeling ready. That's good, and keep it up. Cool. We're going to start now. So good luck to everyone. Let's see how this turns out. A quiz question to start. What is an alpha particle? Is it a single proton, a helium nucleus, a single electron, or an EM wave? Which one is it? So answers have come dripping in. There's a few more left that haven't answered. What are people going to put? Hopefully, this is a fairly straightforward one to start with. For those of you that are there at the start and also have done this topic before, it should be a fairly straightforward answer. 2 people got it wrong. 2 people got it wrong. So the majority got it right. It's good to see. It is a helium nucleus. Yeah, I kept saying it had a mass number of 4 and an atomic number of 2. It's the first thing I wrote today as well. It is a helium nucleus, a positively charged helium nucleus. Why is yours not working? What do you mean it's not working? Could you not click on an answer? I don't know if it's a... Sorry about that. I don't know if it's an internet issue then, because obviously people have joined, people have answered. I see obviously you had the 15 people. So maybe you were the one that didn't answer. Don't know. It stopped abruptly. It's happened to someone before. That's really unlucky. I think it's your end. I'm sorry about that, but yeah, I think it might be your end, unfortunately, Debashri. But it's not too late. Don't worry if you've got it wrong or you haven't got a chance to answer. Please do join in, Debashri. It's fine. You could try and join in again now, and hopefully you can get back into it. So How does that leave the leaderboard? Remarkable Kangaroo is in the lead. No one got 100,000. No bots in the chat. That's good to see. Classy Ostrich close behind, 7 points behind, and Clever Echidna just 2 points behind. Royal Panther another point behind, and Friendly Newt another point behind. Really close. Top 5 separated by 11 points. It's exactly what I thought it might be. Someone said, Sammy, you're 5th. I'm sure you're not that far behind either. I'm sure your points are probably pretty close as well. Cool. Next one up. Let's do it. What's it going to ask us? It says a true or false question. So those of you that were in Neen's live, you would have seen this before. Radioactive decay is random. He gave you the tip. I think people have taken the tip. Spam that button. If you know the answer, you know true is on the left and false is on the right. They're not going to be the other way around. We wouldn't be so cruel as to do that to you. And I've checked you can't do it anyway. So true on the left, false on the right. I think there's a couple of people left to answer. It says 16 answers. Debtree, I'm hoping you managed to answer this time. Spam didn't work this time. Oh, it doesn't work. Okay, yeah, fair enough. If it doesn't, I mean, I guess it's like if you click on the right side of the screen, it doesn't let you spam. Okay, well, as long as maybe your mouse is in the right position, you put it in the right side, you know, left is true, right is false, and then just be ready to click when you can. One person got it wrong. Radioactive decay is random. Yeah, I mentioned it. I specifically mentioned it, talking about rolling a dice and getting a 6. It's a very random chance of that happening. It's 1 in 6, but it doesn't happen every 6th go. Yeah, it's very, very random. How does that leave the leaderboard? So a couple of people dropped. Friendly Newt has risen. Remarkable Kangaroo and Classy Ostrich. We still have the same top 2. Again, separated by 7 points, and they both got 1,000. So I don't know if they spammed or not, but they hit it rapidly, yeah, right on the dot as soon as they came out. So whoever they are, Philip is one of them. You, it may be. I have a sneaky suspicion. You never know. Inspired Axolotl, what a name, has climbed into the top 5. The top 5 only separated by 32 points. How do you get 1,000? 1, internet connection. And number 2, like I said, some people are spamming it, Philip. I think you can, if you click on it, you can sometimes just hit it fast enough. I've seen some more people join the chat as well. If you want to join, the Kahoot code is here, 4443613. If you just want to take part, have a bit of fun and test yourself, please do join still. It's never too late. Just take part. Yeah. Cool. Let's see. So how do you get 1,000? Suggest to me Philip isn't in the top 2. Or is he trolling? Let's see. Next. Quiz question. Multi-select. Which types of radioactive decay cause a change in the element? Yeah, so which ones, when you emit it, causes the resultant particle to then decay into a different element? So I didn't mention this directly, but I talked about how each of the interactions happen. So you should know, based on what we covered today, which ones are correct. Got a few more left to answer. 23 people in the chat. If you just joined, do join the Kahoot. It's 4443613. So, a couple of people made a mistake. Gamma doesn't, remember, gamma doesn't because it has no charge and no mass. It's 0, 0, the 2 numbers I left there, right? So it just emits energy and the nucleus at the start stays the same at the end. It's the very last point I covered before we started the quiz. So it's not gamma. So therefore, automatically, it's also not all 3 because gamma isn't one of them. It's alpha and beta. Alpha, the mass number goes down by 4. The atomic number goes down by 2. So the element changes. In beta decay, a neutron turns into a proton. The atomic number goes up by 1. So again, the element changes. Okay. So those are our 2 answers. How did that leave the leaderboard now? Let's see. Oh, wow. We've had a drop off completely off the map. Remarkable Kangaroo, I think it was, got it wrong and is now completely off the top 5. See, one question changes everything. So don't feel like it's over just yet. Classy Ostrich now takes the lead, is our new leader with a gap of about 61 points ahead of Powerful Elk. So it's still pretty close, and Friendly Newt closely behind in 3rd place. Again, Clever Echidna is also quite close. So the top 4 are pretty close. Purple Mandrill is just behind a little bit, but as you just saw, if people get them wrong, they are flying down the list. So close to the podium, Philip. Again, is he trolling? Is he not? Let's see. And we'll move on to the next question. Also, shout outs to all of you that have got all 3 right so far. Well done. Cool. Next one up. Quiz. What is the unit for radioactive activity? Is it Joule, Sievert, Becquerel, or Tesla? Which one is it? Hopefully should be pretty easy. I only spoke about one of these today, so this is how I know. If you're in the class, you know it was one of them. My internet connection was gone, so I didn't answer a question. Oh, that is a shame. You know what it is? It's the bad weather disrupting all the Wi-Fi particles. I always love to say that. It's always a problem. It's always a problem for people internet. I always have it at home as well. Sorry that that's the case, but it's not over. It's never over till it's over. Philip, this might be tricky because of Sieverts. Exactly. Yeah, threw in a little curveball, but only one person fell for it. Yeah, sieverts is for radiation dose, and it's a triple science topic. Becquerel's is the measure for decay. I said this, the scientist that named it after himself, the number of decays per second. How does that leave the leaderboard? Classy Ostrich still in the lead. 57 behind them is Powerful Elk on a streak, an answer streak of 4, as a few of you do have. It's all very close. Clever Echidna on 3808. Still in with a chance. Friendly Newt as well. Raw Panther. So whoever was fifth, I think, last time has dropped off. So they've dropped off. Another change in the leaderboard. Let's see how many more changes we have as we go through the quiz. Next question. Question 6 of 12. We're about halfway. What is alpha radiation stopped by? Is it aluminium foil, paper, concrete wall, or lead block? Which one is it? It's midnight for you. Ah, no, that's a shame. So you would expect that. Uh, Either you maybe you're a bit tired. Have you got any answers wrong? I don't know. It was you. Yeah, no, yeah, I don't think it was you, was it? Technically, all of them. Yes, yes. But what is the first thing that stops it? It is paper. It is paper. Yeah. One person got it wrong again. I want to see one where everyone gets it right. Hopefully, we get there. Just one short. Aluminium foil is what stops beta radiation. Concrete and lead stop gamma radiation, and alpha is stopped by paper, a thin sheet of paper or a few centimeters of air. Let's see how that changes the leaderboard. Another change in the top 5 at the bottom there. Purple Mandrill was there before. They're back in it. They're back in it again. Definitely in with a shout for that second spot, I think. Although actually just Powerful Elk and Classy Ostrich are having looked like they're forming their own battle. Is that going to continue for the rest of the game? Let's see. Clever Echidna is hanging on in there. One mistake from either of them and you get into the top 2. So keep pushing. Keep pushing, everyone. Cool. Just past halfway. Let's get into the next question. A pin answer. Which is the correct symbol for gamma radiation? So drag your pin to the correct spot and press submit. Let's see who got it fastest, who got it right. Hopefully, people didn't get it wrong. Hopefully not. Processing is too slow. It's a shame. It's a shame. Stay with it though. Remember, the ultimate aim is that you're getting the questions right. Yeah, I wanted you to learn from us today, and hopefully pick up that you understand this topic well, and getting the questions right ultimately is the right thing. If you've gotten it a bit slower, it's okay. Um, it's a shame that it did. I'm sorry if it did lag for you. Unfortunately, on Kahoot, it's not something I'm in control of. It's an internet thing. Yes, everyone got it right. Everyone got it right. I was saying I wanted to see a question where everyone got it right. Love it. It is gamma. Everyone knows that. We spoke about it earlier. 4 and 2 is for alpha. 0 minus 1, a high-speed electron, is beta, which leaves the no charge, no mass wave as gamma. So well done, everyone. How does that leave the leaderboard? There is a change again. Royal Panther and Mandrill. I forgot what the first name for Mandrill was. The Mandrill and the Panther are having a bit of a battle there for that 5th spot. It's looking interesting. I think Debashri said she was, or someone else said they were 5th actually. And Sammy, you're 3rd. Are you still 3rd? Oh no, Sammy was 5th, so now you're 3rd. So you're Clever Echidna. Nice. You crept up there. You can creep up to 2nd now. Swift Mole with a high streak of 6. Nicely done. Classy Ostrich has stretched their lead now. It's about 50 points. Can anyone catch them? We will see. On to question number 8. Puzzle. Put the following types of radiation in order of ionizing power, from the most ionizing at the top to the least ionizing at the bottom. Who's going to get this right and the fastest? Yeah, drag them around. When you're happy with the order, press submit. Who is going to get this right? Will someone make a mistake? Will someone try and be too fast and get it wrong? We'll see. 24 people in the chat. Guys, if you're not in the quiz yet, please feel free to join. The Kahoot code is 4443613. www.kahoot.it. Yeah, or feel free to message in the chat. But some people might troll in the chat, so just be careful if you are answering it. Lock in on the Kahoot, and hopefully you will get the answer right. Just a couple more people left to answer, I think. Let's see what people get. A couple more seconds left. Here we go. Let's see. Everyone that answered it got it right, it looks like. Nobody got it wrong, so everyone answered it, but one person, it was 16 before, now it's down to 15. But everyone got it right. Nice. Good to see. Alpha is the most ionizing. Yeah. Beta is the moderate one, steady Eddie in the middle, and gamma is the least ionizing. We so smarty pants. You're right. Everyone is doing well. Yeah. Nice to see loads of people are getting it right. Yeah. This is a topic people said was hard, but people are getting the answers right. So it's good to see. If you haven't, remember, you learn the best from your mistakes. Every lesson learned is a good thing. Okay. How does that leave the leaderboard? So Classy Ostrich extending their lead a bit more now. It's over 100 points. Can anyone catch them? Will they make a mistake? Second place is definitely up for grabs, but can anyone capture Classy Ostrich at the top? I'm not so sure. Yellow Yeti, you're a kidna. You're in with a chance. 12 points. It's so tight between you two. Is it going a bit faster over the next few questions? Can seal it for you, or will Powerful Elk, will you pressure them into a mistake? Who knows? Let's see. On to question number 9. So 4 more left. 4 more left. Quiz question. What change happens to the atom of an element that undergoes beta decay? Is it proton to neutron, electron to proton, proton to electron, or neutron to proton? We discussed this a few times. I did repeat it several times. What is the change that happens in beta decay? If you think about the equation, we said it changes element. How does the element change? That will give you a clue. We went from, I think the example was carbon to nitrogen. Ow, ow, ow. That was painful. A real mixture of answers here. It is the last one, neutron to proton. I said a neutron changes to a proton, didn't I? Yeah, if I go here, we said at this example, the mass number stays the same. The total number of protons and neutrons stays the same, but the atomic number, the number of protons went up by 1. So that would have narrowed it down to our answers on the right, either an electron to proton or a neutron to proton. But the changes in the nucleus, the nuclear number or the mass number, stays the same. So 1 neutron turns into a proton, and I've put it here. A neutron turns into a proton. Yeah. So for those of you that are paying attention and got it, well done. Unfortunately, for those that didn't, but it's a lesson. Yeah, neutron turns into a proton in beta decay. If there's one thing I want you to take away from today, it's that. When are you going to do Half-Life Strawberry Cheesecake? Not in today's session. We obviously cover it in IFRL classes. We will do it in the boot camp, but the quiz today isn't on Half-Lives. I was swindling your brain. I know these are the questions. I knew this question would be a bit tricky because I thought some people might click proton to neutron quickly seeing those two words. Just a little trick there, but it's okay. If I'm swindling your brain, I'm sorry. I'm trying to help you here. This is the bit I want you to remember, okay? To unswindle it, the one thing I want you to know, beta decay is when a neutron turns into a proton in an atom. How does that leave the leaderboard? Classy Ostrich has dropped. Classy Ostrich has dropped. This is what I was saying. It's never over till it's over. Classy Ostrich made a mistake, didn't get any points. So Clever Echidna, I think that was you, Sammy. You've gone and risen into second place, and Powerful Elk has taken the lead. 7-6-5-3. It's about 80 points, 72 points between the top two. All to play for. Absolutely all to play for. Cool. So why don't you do double points on Kahoot to make it exciting? We do for some questions. Okay, I don't do it all the time. But looking at it now, it is exciting. Everything's hotted up. There is not a runaway leader anymore. Okay, Powerful Elk in the lead. Will it stay that way with just 3 questions to go? Yellow Yeti, sorry, you're a kid now. Nicely done. How much does the mass number of an element change as a result of alpha decay? Is it -2, +2, +4, or -4? How does it happen for alpha decay? 11 answers in so far. A few more left to go. Who's going to get this right? Is someone going to rush and make a mistake? Is the lead going to change again? Let's have a look. A couple more seconds left. It's always blue. You're wrong, Yellow Yeti. It's not always blue. So if you put blue, you made a mistake. We also in the previous question, it wasn't blue either. So I don't know where you got that from, but there we go. It is -4, guys. I think Yellow Yeti was trolling people. Probably put the answer in too late. But you put yellow +4. It's the 4, right? Because the element loses 4. The alpha decay is emitted, and you take that 4 out. Yes, if I look at this equation, this is the alpha decay, and it comes out of the element. So 219 -4 and -2. So this is the nucleus you're left with. So the mass number has decreased by 4, -4. That's why. Yeah. Hopefully that makes sense for those of you that didn't get it right. I can see why people rush to +4, but that's the reason. The element is what I was talking about. Not what alpha is emitted, what changes. What happens to the element once the alpha is emitted? It loses 4 and 2, right? Because that's the alpha particle that is produced or released. How does that change things? Sammy is on the podium, but where on the podium? More change. More change. There is Clever Echidna, Yellow Yeti. You're right. You didn't get that right. But again, it's not over till it's over. A couple more questions left. Will you be able to catch up? Powerful Elk has taken a lead. Is it an unassailable lead? It was initially for Classy Ostrich, but they lost it. Classy Ostrich is now in second. Will they get it back or not? Let's have a look at the next question. Much question, what is most commonly used as a source of nuclear fission? Which one is it? So there is a radioactive element here. One of them is radioactive, super radioactive. Which one is it? It's one that you see glowing green. You see it in The Simpsons quite a lot. This is quite a difficult question. Um, this one actually is actually a topic that comes at the end of radiation. Yeah, so it's not always blue, yellow yeti, but in this case, it is blue. It is blue. It's uranium. Yeah, uranium is the most abundant source of radiation. Yeah, Debashri, nice, you got it right. Let's see how that changes the leaderboard. Let's have a look. The top two are still the top two. They are still the top two. Clever Echidna has gone to fourth. Royal Panther has gone to third. Let's see if that stays the same for the last question. Let's see how that looks. Powerful Elk looks like they've got it in the bag if they get the next question right. Let's have a look. If everyone's ready, the final question. What is the missing product from this equation? So it's not going to show up straight away. It's going to reveal itself. Look at the equation and think about what the product is going to be. What type of decay do we have? We have a particle with 10 and 4, and it becomes 10 and 5. So the mass number has stayed the same, but the atomic number has gone up by 1. Everyone's answered it. Everyone's answered it pretty quickly. It is, most people have got it. It's a beta particle. Yeah, remember, the mass number stays the same because the neutron turns into a proton. Yeah, so the atomic number therefore goes up by 1. That is how you get a beta particle being emitted as the product. Cool. So that is it. How does that set up our podium? Let's have a look. We have in third place Clever Echidna, Yellow Yeti. You made it. Debashri was the bunny. Where does that leave the bunny? You said you were seventh. Unlucky. Classy Ostrich in second, who lost the lead at about question 8, leaving Powerful Elk as the winner. Congratulations to Powerful Elk and Classy Ostrich. Honorable mention for the runners up for the Royal something, I forgot. Royal Panther. Royal Panther was fourth, and that was the Mandarin in fifth. Unlucky. Who is the elk? Whoever you are, congratulations. Classy Ostrich, whoever you are, congratulations. Remember, if you are one of the winners, please send us a screenshot of yourself on the podium. We can see your character at the bottom, so we're going to know if it's you. So don't lie, okay? If you are the winner, send to our email at help@flashrevisionlab.com. Send us a screenshot of that, and also a screenshot of you messaging me in the chat during the revision session. You send us those 2 screenshots and tell me I'm the winner of the quiz. Please, can I have my voucher? We will send that to you. Okay. Thank you very much. Well done, Mohammed. If that's you, send us your screenshots and we will send it to you. Well done. You got a 5.5 in GCSE combined science in December mock exam. Do you think revising 1 hour every day from now on would take me to a 7.7? How useful that revision is, it all depends on how useful that hour is. Yes, if you do a question practice that day, as well as looking at notes, that's the best way to do it. Yeah, but as you get closer to exams, you may want to up that a little bit, especially over the Easter holidays. Yeah, at any time, the Easter break is where you want to up that a bit more. But on school nights, an hour is, I would say, an hour is great each day. That's a good amount. Okay, well done, guys. Before any of you go, I just want to say the next live is going to be Neen's live, and it's going to be on TikTok, guys. Okay, so that's going to be on TikTok. Keep an eye out on our socials. It will be on TikTok. If that's an issue, we will find a link. We may put a link out on the YouTube to give you a link to the Kahoot, but it's going to be on TikTok. Okay, so we're going to join there just to see how it goes. We won't always do it. We're trying to mix it up. Sorry, Debashri, maybe just not on this occasion, but we are trying to do it for a mixture of both, okay? Because we haven't done any on TikTok. We just want to see how it goes. We have a large following on there. YouTube, we will come back to. Keep an eye on our socials. We will come back to YouTube again. But we're just going to TikTok because it's our largest following as well. So if you wanted to get TikTok and follow us on there, okay, a lot of people are with us on there as well. All the videos that we get on YouTube are on there. The only thing is the live classes. Yeah, and so far these lives, but we're trying to move the lives into between the two, okay, so that we can do TikTok and we can do YouTube. But for this one, it's going to be on YouTube. Please do join us if you can. If you don't have the app, do get the app and join us, subscribe to us, and you'll see us on there. And we'll be doing the same thing. And other than that, one last time, guys, we're doing the boot camps after this week, our last session on FRL classes. Then we'll have 2 weeks for Easter holidays. I've put the link in the chat. Do join us on there for paper 1, which is completely free, and paper 2, just £10 a class. If you want to join FRL classes, it's only £22 for the lot instead of 30. So please do take a look, click on the link, sign up, and we look forward to seeing you there soon. thank you for the time today. I'm going to stay on for any last questions for a minute or so. If you've got anything, drop it in the chat. Otherwise, have a good rest of your Sunday evening. Enjoy the rest of your Mother's Day with your mothers if you can. And we'll look forward to seeing you very soon. I have a question. If the Kahoot code will be only on will be on YouTube, and if I win, then would I be able to get the prize even without participating in the live stream? So that on this occasion, we will see how it goes because TikTok is harder to manage the people, so it will be more based on the quiz. Yeah, so you can still join. Um, what did I do in uni, Philip? I did chemical engineering. So Nina and I both did chemical engineering at the same university. It's actually how we know each other. Yeah. So I did chemical engineering. I did maths, further maths, physics, and chemistry at A level, which I found the best way to get into that. And yeah, I just knew I wanted to do engineering of some kind. And yeah, I went to Imperial to do that. So yeah, it was good. It was a good experience, a great university. So yeah, it was a good experience. If I buy the subscription for FRL classes, so for £22, do I get all the resources for the same price as FRL Pro and FRL Pro? Yes, you get FRL Pro, everything on the website, and you get all these resources. You get all the live classes, you get the workbooks, you get the boot camps, you get the revision guides, you get all of that and everything that you already get with the FRL Pro subscription. So all the questions on the website, all the flashcards, all of that. You get the whole thing with FRL classes. That's why it's beneficial. Yeah. And it gives you all the boot camps, which otherwise would be £30. So please, if you are interested, I would recommend going with the subscription because you just get so much more for it for a lower price. Yeah. What grade did I get at GCSE? I got 8 A stars and 2 A's. My 2 A's were, what were they? English language and something else. I forgot what the other one was. But yeah, 8 A stars and 2 A's at GCSE. I'll try and be on. If not, can I join the quiz without being in the live stream and win? Yes, Devonshire, I'd love to see you there if you were the winner. You've been here enough. Do join us. That's why if we'll try and put if we do put the code on YouTube and you can't join us on TikTok, it will be done based on the quiz. Yeah. So if it is there, do join us. Just join us and take part. Because on TikTok comments fly through, it's a lot harder to manage that kind of thing. So we'll be basing it off of the quiz. How many hours a night did I do for A levels? It varied, right? So I did about an hour of each subject. So I said because maths and further maths was kind of one, so an hour of maths, an hour of physics, an hour of chemistry. So I did about 3 hours a night. It was more like 30 to 45 minutes before that, like at the start of the year, and then maybe by the turn of the year, because we got to like for us at A levels were different as well because we had modules and the exams some were done in January, whereas now all the exams are done in the summer. So I had to revise a bit more when it came to winter. So that was a bit of a different variation. So as it got nearer to Christmas, and like in like October, November, I was doing like an hour of each, and then that kind of continued throughout throughout the summer as well, through to the summer. In the spring, I kind of increased that, went up to about probably 2 hours of each subject. So I was doing six or 7 hours of work a day because we were off school. It needs it. It's a lot more content, guys. A level is a big jump. How many hours did I do at GCSE? That is different, right? Because you can't do an hour of each subject every night. But I'd do maybe an hour of 2 subjects, something like that. So like 2 hours or maybe 45 minutes of 3 subjects, something like that. So I try to do 2 hours of revision basically every night because after you get to about maybe 2.5, and then once you get there, it's too much time. You need time to eat, you need time to rest, you need time to sleep. Your brain needs to calm down as well. Yeah. So don't overload it with revision because that's the problem with doing it last minute. You overload yourself with a revision and it's just too much to take in or too late. Some people work miracles with it, but I wouldn't recommend it. The best way is little and often and regularly. Yeah, just keep regularly testing your brain. Do something you did last week, bring it back a week later and see, do I still remember it? Then leave a gap of another week. Do you still remember what you did 2 weeks ago? And so on. Yeah. Yeah, I'll don't worry. Nina's aware. Devonshire. Don't worry. I'm just letting you know, really on his behalf, because he will be doing the next live that is on TikTok. So that's why I wanted to make you all aware. You guys have been there for every live, so we just want to make sure you're part of everything that we're doing. How do you active recall? I mean, there's different ways you can do it, like asking someone else that you don't know, or like not that doesn't know what you're saying, and you're like basically explaining it to like a random person. Going through your notes, you give them your notes, and you just talk at them, and you go, hold this and read through it. Am I saying everything that's on there? That kind of thing, or doing it yourself, like turn the page over. Once you've written everything, then say it out loud, and then turn it back over and see what you've missed. That kind of thing. That's what I would do with active recall, and I used to do that with some of my notes for other subjects like geography and subjects like that where I needed to remember more facts. How do you revise in A levels? Because yeah, same subjects as me. Honestly, loads of questions, loads and loads of questions. Yeah, practice papers and stuff like that. But obviously again starting with notes, so making my own notes. But then from there, doing questions on all the topics. And then as we got to, by the time I got to like Easter, it was papers, 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 practice papers. Marking it myself. Where did I go wrong? Going back again, and then cycling through them again and again. Where will the boot camps be visible and accessible? You will get all the links to your email. Yeah. So if you once you sign up, we ask you for your email. Everything will come to your email on how to join, where to join, links to join, times to join, all of that. Yeah. And on this link, I'll send it one more time here. The link that I gave here, this is where you sign up. And on that page, you will see all the information you need to know about times, how each day is split up in terms of sessions. All of that will be on there. So please take a look and sign up. And we look forward to seeing you there. Thank you very much, everyone. I'm going to jump off now. My throat is sore. I need a drink and I need a bit of a break. So thank you very much, guys. Love seeing you all here today and taking part. Love the chat. It's what makes this enjoyable. And look forward to seeing you more in the future. And take care. Have a good rest of your weekend. See you later. I already have FRO classes. You don't need to do anything. You don't need to do everything. You've got everything. You're right. You have everything that is stated. You will have access to the boot camps. You will have access to the revision guides that come with it and the classes as usual. So you don't need to do anything if you're on FRO classes. That is why we say it's beneficial. Everything will come to you if you do FRO classes. So no problem. Thank you very much. Hatim, sorry, I've said that wrong. Thank you very much. Thanks for coming today. Take care. Have a good evening. I'll see you later.